Hi everyone. What I've got for you today is, well, it's not a repair in that I'm not finished my attempted repair of this, but this project has lingered on for quite a long time and I don't really have time to get into the next stage of it at the moment. And as you'll see, there have been multiple stages of attempts to repair the power supply of this. I'll show you what it is. It's a Mission MS200 subwoofer. What is this? I don't know, 150 watt, 125 watt, I think actually. A subwoofer amplifier for a relatively small sealed enclosure. Subwoofer is nice in a relatively small room. Sounds okay, but this started blowing fuses and eventually stopped working entirely. Well, it blew its fuse quite spectacularly, actually. Eventually, it had trouble starting, and I've replaced a number of parts on this, as I'll show you in the video that follows. And as I said, it's a busy time of year at work for me, so I haven't had a whole ton of time for this. So I've been just blindly replacing the parts that seem to be bad for me with, wait for parts to be delivered in time. And now I'm at the point where I've replaced everything that seems obvious to me, and it's still not working, so now I've got to actually understand the circuit better than I do, and that's what I don't have time for. So this is going to get put aside, and that's why you're going to see in what follows part one of the video about this amplifier or this power supply. I'm assuming this board, this is the amplifier board. You can see the two Class D amplifier chips that it's using there. And this board here is the input board, right? You can see the input there and, the crossover phase switch and auto sense, which never worked properly on this. You can see where I've gummed up the fuse holder changing the fuse. Yeah, so what follows is going to be mostly handheld, almost entirely handheld video of me trying to troubleshoot this, the various steps I've taken, and where I've got to with this project. I'm still hopeful that I'll be able to fix it, but I need to understand what's going on a little better than I do. And to do that, I need to understand the data sheet for this chip, which seems fairly straightforward, but we'll see. Oh, I apologize, there's the heat turning on. You can probably hear the air in the background. So, yeah, that's what I'm going to show you. And if you have any advice at the end of this whole thing, if you stuck with me through part one of what's hopefully part one of my attempts to fix this, then if you have any ideas about what might or might not be wrong, I'd really appreciate hearing about them in the comments. Well, good afternoon, everyone. This is probably going to end up in the realm of failed repairs, but we'll see. This is the power supply out of my subwoofer. Here's the rest of the subwoofer. This is the amplifier board, and this is effectively the preamp board, which has, on the other side, the inputs and whatnot. What's failed on here is the power supply, I think, which has drawn a lot of current, blown the fuse quite spectacularly. I've ordered some more fuses, but I wanted to have a look at the board, and I was expecting, well, I don't know what I was expecting, but I was expecting to see a fairly high current draw when I put this on a meter. Well, let's see if I can do this with one hand. Well, not very well planned here. That's all right. We just need a rough number here for our purposes. Let's see. I don't do this with one hand very often. Okay. So we can see it's reading about, 0.5 mega ohms. So that like, that seems all right. This MOV hasn't warmed up yet, so it shouldn't be drawing much current. If you flip the polarity around, it's a bit weird because it's lower. I don't know why that would be the case, but there you go. But that's still, right? That's still 335 mega ohms. That shouldn't blow the fuse. So, so how are these things supposed to work? Well, my knowledge isn't great, but, it comes in. This MOV keeps it from blowing the circuit as these capacitors charged up. They're chokes and capacitors on the input, all fairly heavy, all like nicely made. There are what looks like 1, 2, 3, maybe 5 amp diodes. Some blue capacitors across that, and we also have some across the line caps here with some shielding. This whole thing, this whole board is potentially live, right? So not the easiest thing to work on in some ways. They've actually got warnings on the heat sinks. Then we have the output transmitter. So it's a transformer. So it's a switching power supply, which is fine for a subwoofer. Shouldn't be any issue with that. Yeah, so it seems reasonably well built. So I'm looking, I don't know how, I don't have a manual for this. I don't, this is all, as I like to say, beyond my pay grade. This looks like an 8-pin chip that seems to be perhaps the brains of the operation. Everything else seems to be passives or a few transistors, and of course 1, 2, 3, 4. Presumably those are the switching transistors on the power supply. There should be another set of diodes here somewhere. That I haven't found. Or at least one. Maybe we've got diodes on one of these. That would actually make sense, that this side here might be the 2 diodes coming out of the regulated side. Anyhow, so I look at this and I'm going, if it's something not obviously broken or that you can't test, like with this, I'm probably not going to find it. And then I look at that. That's a very bulgy looking capacitor. And that looks to be the startup power supply capacitor for our little chip. That's very bulgy. So if this chip is not adequately controlling the current that this whole thing is pulling, could that blow the fuse? Maybe. Anyway, as I said, I've ordered some fuses, and I'm going to try to have a look at what that capacitor is and see if that's one I've got. If not, I will order some capacitors as well, and maybe make an attempt to fix this thing. Everything else looks like fine. It's well, I mean, to the extent that I understand these things, it's well made. It's a single-sided board. It's like, it's nice, right? Not badly done. There are no fins on these heat sinks because they rest within the sealed cabinet. This is a sealed cabinet subwoofer. What would have been called acoustic suspension, but probably really isn't because there's a rubber suspension on the woofer. But so these are just these are an attempt to spread out the heat dissipation as opposed to spread it out and then spread it into the air. So yeah, there's presumably temperature sensors on here as well, though it might be built into the MOVs that are being used. For the amplifier chips, of which we have 2 right here, couple to the outside of the housing, and then there's a finned heat sink on that, which at the relatively restrained volumes I tend to run at gets barely warm to the touch. All right, I have succeeded in desoldering the capacitor. Here it is. Looks pretty bulgy. Let's see what happens with the capacitor. Well, the component tester here. See if I can get it in with one hand into a couple of pins here. That's very fiddly to do with one hand. All right, let's see what we find out. So 283.1 nano. However, that's not what it's supposed to be. It's a 10 micro capacitor at 50 volts. What I've got is a 25 volt Nishikon, and I also have the ZSF that I can't remember what that comes from now, but these are fine if I remember correct. This is a 400 volt capacitor. If it fits, I would just stick it in probably. My memory is that these are all right. Oh, well, if you don't have it in, maybe I'm wrong. Well, that would answer the question of what to use fairly quickly. No, oh, those are not good. Okay, so even though it's 25 volts as opposed to 50 volts, I think it's going to be fine because this one over here is 25 volts. It seems to be across the same rails, so I think it'll be all right. If this does blow up, I can replace it. But what I do want to show you is that I know why it blew, why this one failed. All right, so let's go down here, and you can look. See that red pen marking? That's where the capacitor went. But you'll notice I've marked it red on what's the negative marking for the capacitor. I marked it red because I marked which side the positive side was when I removed the capacitor. But you'll notice if you look at the, and there's also a red dot over there, which I also put on earlier on. But you'll notice if you look at the silk screen below, that's the negative side. They installed the damn thing backwards, and that's why it blew up. Unbelievable. That's something I might do. Anyway, so I think what I'll do is I'll put that Nishikon in there for now. Maybe I'll order some 20 volt, some 50 volt ones. But I think I'll probably put that one in for now and see what happens. Okay, I may change my mind on that because I did test the ZSF one. Well, this is going to be impossible to do with one hand, but I tested the ZSF one by holding it on this pad. I think these little pins weren't getting in deep enough, and it tests fine. So what I think I'm going to do is I'm going to change my mind. I'm going to solder some leads onto that, and I'm going to put this one in instead. Then we don't have a voltage issue. Again, I don't think for this purpose it's that crucial, but let's not have to open it up again if we don't have to. Okay, so here is this 10 microfarad capacitor with the leads extended. So that will hold it, because it's bigger, that will hold it up above the board here. If need be, it can be hot glued to something there, but we'll see if it works first. Anyhow, so there it is in place. As I said, I could glue it over here and probably will if it works. The other components on this board are generally glued together to protect from vibration, which makes sense in a subwoofer. So I think I'll just glue that to this. I assume that's a capacitor in there. Can't tell. Anyway, I will glue it to that, again, assuming it works. Well, but I'm going to have to wait to get a fuse, and then we'll see if we get any sparks. Should be exciting. My fuses have come in, so I'm going to try to get this power supply module going. I've done a little bit more poking around just before I do that, and I've checked a few things. The first thing is that I think these are transistors, and these on this side are the diodes. They are actually insulated. You can see there's a little layer of insulation material between them and the heatsink here. The same on this side. I have tested between this lug, which I think is the ground, and here, and it does in the case of the MOSFET, I guess, does get hot briefly when you put it on, and then of course the capacitance stops it. So you get a beep when you first test it with the meter, but not between the case of the MOSFET and the heatsink. So in fact, it is double insulated. That's the first layer of insulation, and then the board is another one. So I think this is fairly safe to handle despite the scary warnings here. We'll just read those as generally telling us that this thing is hot. The other thing I did is I looked over here on the amplifier board, and we can see what the output of the power supply is. 27 volts, ground, minus 27 volts, and mute. So as an amplifier that does claim to be 150 watts, we would expect to see about 50 volts across it. And that's mute. I don't know what that is. That probably shuts the power supply down. And there's the ground. So we can test up here to see if we're getting our rails out. We might not, because there's no signal going into the speaker. So we'll see. Going into the other board here, we see signal coming from it, ground, and it says NC. And for the power line that goes out to that board, I don't know what NC stands for. We've got minus 12, plus 12, standby, and ground. So we essentially have a sense line between each level at least. We have a signal line, and of course each has its own ground. So there must be a regulator on here which is producing the 12 volts for this board over here. I wonder if we could see that if we look at it. Not obvious to me, but must be there. Oh, well, we have two. Well, I'm not sure. Anyway. Well, there are a couple of other elements. We've got two speaker lugs there, so it looks like there might be the possibility of driving two subwoofers off this amplifier if you had it in an appropriate cabinet for two codes. I don't know. There we go. Oh, no, that's a bracket. Anyway, and there clearly is some other electronics here for possible other purposes. Anyway, I'm going to put the fuse in, see what we see, and we'll take it from there. So I found the 3.15 fuse. I'm going to install this board the other way around, back in place here like this, and then I'm going to plug it in and we'll see what the power rails look like coming out. Okay, it's plugged in, the fuse is on, the moment of truth. So that's interesting. It drew a lot of current on startup, but I don't think the fuse is blown. Let's have a look at the power LED. It's off. So I think we may have taken out the fuse again. Let's see what we got here. So the answer is the fuse did go. Wonder why. I'm back looking at this, and as I said before, it's still blowing fuses. So I have looked around to try to understand the circuit a little better. This chip, which number is IR21530, is essentially acting like a, I mean, it's even described in the data sheet almost like a 555, like a very high voltage 555 in H-bridge mode. So it's driving these two, presumably MOSFETs here. That could be toast because of the capacitor, which maybe I misread which way the other one was in, but maybe. The other thing that I was thinking of was, maybe the inrush current protection device wasn't working properly. Maybe it got toasted by me flipping it on and off a whole bunch of times trying to see if I could get it to start. So I actually ordered them. That's labeled SLK104, I think, on it. Something like that. It's on the other side. Yes, you might be able to see it here. Sorry. Probably not. SCK104. And I was able to poke around, and that's a pretty standard current inrush limiter. So I have ordered some of those, but I did test it and found that it has 10 ohms resistance at no current. And according to the data sheet, that's correct. It should have 10 ohms resistance, which then falls down to less than half an ohm as it warms up. So that seems to be functioning correctly, even though, I don't know, the color kind of looks off. It looks cooked to me, but maybe that's just because it's against my green mat here. So then I thought, okay, well, let's poke around. Let's see what's going on. So I'll show you what I did. Again, since for some reason I've decided to do this whole video handheld. So these are the two capacitors on the back. This ties them together as the neutral, and this here is the hot side, and they're tied together as well. Let me put that on beep so that we can hear it. But I'll also put it over here so that maybe I can show you. All right, so these are tied together. There we go. Right, and that is the outside of those. I'm sorry, let's see. Okay, now I'm a bit confused. Let me have another look. Be right back. So this is the negative, and that's the positive of this capacitor. This is the negative, and that's the positive of that capacitor. They're tied together in the center. Here, we'll do that again. Negative, positive. You can almost make the circle out underneath from the other side of the board. Same thing here. So that means that they're not in parallel, they're in series. And it's got something pulling from the center of the two of them. I'm not entirely sure why it's done that way, but that's the way it's done. But if you test between these two, but that doesn't make sense if they're in series and not in parallel. And this is where I started to get a bit surprised. So what I decided to do was I decided to say, well, what could be shorted here? And these over here are our MOSFETs, right, on this heatsink over here. And as you can see, they're connected, one on this side and one coming around like this. I can't remember. It does come over and connected to this one here. And this should be the ground plane. Anyway, something like that. Anyway, but this is what happens when you start to test them. Yeah, here's the other one. Everything's all shorted out. So I'm not going to do it today, but I think the only solution is to pull those MOSFETs out and put them in a tester and probably order a new set. One or both of them, and actually based on some resistance numbers, I'm thinking maybe this one. Is shorted out. It's also possible something on this chip is sorted out, but that chip is rated, it might act like a 555 mainly, but it's rated to 600 volts. So, I don't know. There could be something else shorted out around there. I'm going to go use the meter and poke around and see if the resistance numbers give me any indication of what's bad, but you know, I think these are probably the most likely suspect. Anyhow, we keep digging into this thing. Okay, I lied and decided to remove them. They came out quite easily with the solder sucker and and some solder wick. So there we go. So there they are. I've marked with colors on the top to keep track of which one was where. We'll let those cool down. I'm going to get the numbers off them, then I'm going to get out the component tester and see what it tells us. Okay, so the MOSFETs are out, and if you'll remember, on the two sides of our capacitors here, right, so this is where they're tied together between the two of them, but they're supposed to be in series, and they were showing as in parallel. And that is no longer shorted across there. And if you try just a few, so the only one that beeps is the one that's the same track, right? Because there's going from there to there. And so I don't think there's any short in this circuit anymore. And I'm very tempted to plug it in, potentially sacrifice a fuse, and see if it turns on. Shall we try that? I think I want to. Okay, it's plugged in. Here's the moment of truth. I didn't hear any bang. Let's have a look and see if the LED's on. It's not, but it probably requires this power supply to work, which of course it won't. I did pull this board out. Let's unplug this before I poke around anymore. And maybe we'll check the voltage here and make sure it's bled away. Oh, it's down to 28 volts. That's good. It was over 300, right? So, yeah. So, it's working. In the sense that it's not blowing up. I did try to see if the chip, which is under here, seemed to be starting and seemed to be doing anything. And I checked the voltage across here and it's all over the place. So I still wonder about this chip, whether it's functioning properly. But it may be that it can't without the MOSFETs to get the whole thing going. I was sort of hoping to see something that looked like the drive on this. I may try some more, but I'll have to look at the pin out for this. But it is interesting. So I guess I should order those MOSFETs and give them a try. So I was able to read the number off of those with magnifier, and they are IRF 740s. They're both the same. And what they are, the light is shining there, they're N-channel MOSFETs. Right, 10 amps, 400 volts, pretty chunky component, and 0.48 ohms. So let's see. Oh, always forget. So here we've got the characteristics which we can look at when we put them in the component checker if need be. Well, I'm going to make an attempt to change these MOSFETs. The first step is going to be to remove this insulating material and transfer it to the new ones. There's also a little bit of sleeving, which you can probably see here on the center pin. I'll transfer that over as well. And I'll also need to clean off the thermal paste here that's on the heatsink. So I'll do that with some alcohol and transfer everything over. Then we'll solder these in. I don't have super high expectations for this, but we'll see what happens. Power plugged in, contact. No explosion. Power switch is on. Okay, we'll check DC voltages on the output and see what's going on. Well, I'm going to make an attempt to change these MOSFETs. The first step is going to be to remove this insulating material and transfer it to the new ones. There's also a little bit of sleeving, which you can probably see here on the center pin. I'll transfer that over as well. And I'll also need to clean off the thermal paste here that's on the heatsink. So I'll do that with some alcohol and transfer everything over. Then we'll solder these in. I don't have super high expectations for this, but we'll see what happens. So here's the insulating material removed from the original MOSFETs. We have two little sleeves that go through the screw hole, we've got these little sleeves that went on the center pin on the MOSFET, and this insulating material, which had a small amount of thermal paste between it and the MOSFET, and then more of a gob on the other side, connecting it to the heatsink. So what I think I'll do is I'll get this stuff all set up with just a small amount of thermal paste on the MOSFET side, on this side here. You can see on the old one how they've done it. And then get them transferred over onto the board. So I've put a very thin layer of thermal paste on these. I'll then push in these little things and those and see how it goes. I have them in place here. This one was easy to get in, this one was not. The only thing I'm going to do now is get the meter out and check for continuity between the heatsink and the MOSFETs, just to make sure that I don't have something screwed up with these insulating layers. Okay, I've done that, and I don't, so the next step is to turn them over and solder them in. They're soldered in, and I checked for any shorts. Soldering the center pins is a little bit difficult because it's connected to the heatsink, so if those joints look a little bit dry, they're not really, but it's a little harder to do than you think. Here we are at the moment of truth. Does flipping the switch blow the fuse? No. Okay, well that's good. So let me check some voltages and see where we are. Well, that's not going to do anything because I forgot to plug the power in. Let's try that again. Power plugged in, contact. No explosion. Power switch is on. Okay, well, check DC voltages on the output and see what's going on. I'm getting something weird. I'm getting voltages on this board that go up and down while I've got the meter on it. And I don't see the power light coming on. So I think I'm actually going to reassemble it and see what happens. Just plugging this in didn't seem to do anything. I wonder if it needs to see the load, and if it's not, it's going into the don't start or safe mode or something like that. It's not blowing the fuse. There's, 350 volts between the capacitors and 160, well, 320, I guess, and 160 between each side of the individual capacitors. I can see it on the MOSFETs. The MOSFETs haven't blown up. And I do see using this light that I have above here is a conventional magnetic ballast fluorescent, and old as the hills, and it does flicker very slightly when I turn it on, which I would expect, given that we're filling up these capacitors even with 10 ohms of resistance from the inrush current limiting here. So I'm going to put it back together and see if it works. I think not, and then I'm going to have to think about what's going on. I think the next step in terms of troubleshooting this is going to be to put an oscilloscope on the chip, get out its data sheet again, and see if it's actually producing output on these. But it may not start. It's got an enable, and it may not start if it doesn't get a signal from the amplifier board somehow or another. So who knows? So I'm going to put it back together, and that's probably it for today. And then I'll think about it. So I did do one thing, which was to check the polarity of the capacitor that I'd replaced earlier, which is, yeah, right there. keep my metal screwdriver away from things right now, although it is shut off. And the polarity is correct, and it has about 8.5 volts on it. So yeah, so that I'm fairly satisfied with. I've got to say, I didn't check it on AC just to see if there's any AC voltage through it, but it's a capacitor, so it shouldn't be getting through. Okay, next step is put it together and actually see if it works. So here we are with the speaker installed, and this is just loosely sitting in here. Let's turn it on and see if we get anything. No power LED. So we're still working on this, but we've gotten somewhere. So back working on the subwoofer power supply board. And the next step I'm going to try, so I've replaced the capacitor, I've replaced the two MOSFETs, and now I'm going to try replacing the chip here. And I have, as my tube has come in. So just to give you some idea about how I'm going to try to go about this, move the light over a little. Sorry, we're in wiggle vision still, as we have been for this project. So 1, 2, 3, 4, 1, 2, 3, 4. There are the pins. I don't have any fancy desoldering tools, so I'm just going to try to clear them up as best I can with the solder sucker and see how that goes. But that's really just what my plan is at this point. And fortunately, it's a single-sided board. There are no plated through holes, so it does desolder fairly easily, given these are the MOSFETs here and here that I replaced. So we'll see how it goes. It's now removed. There's the original one. It's scratched up from the pliers to reach it out. And the new one's right here. I ended up using a solder braid mainly to clear it out. I thought the solder sucker would work, but it's too large to get in. So yeah, solder braid works fine. With this lead-free solder, which is what I mostly use around here, you've got to really get the iron hot on the little weller here. That means getting it up to 5, which with this big tip on it really does get it cooking. But once you do that, it was fairly straightforward to desolder. So I'll just go clean up the holes on the bottom to the extent that they need it. They really don't. Well, I'm just going to stick the chip in then and solder it back in. Make sure that there are no bridges or anything, and then we'll give it a try. And so there's the new chip soldered into place. We flip around to the other side. You can see that it actually looks better under the video than it does in person, but a bit of a mess of flux, of course, because tons of flux in the solder braid, and then soldering it in place. So I'm going to clean that up a little bit, and then we'll give it a test. So there's the worst of the flux mess cleaned up over here. Fairly close observation, doesn't appear that there are any little solder bridges or anything that shouldn't be there. So not a beautiful job, but an adequate job. So let the alcohol finish drying off, and then we'll give it a go. I'm going to give this a try in just a moment, but I want to talk a little bit about what I've done and where, if this does not work, and I'd give it about 50-50 maybe if I'm optimistic, where else there could be problems with it. So, as you know, I've replaced the MOSFETs, this capacitor, and this chip, which controls the MOSFETs. My hypothesis is that this capacitor was originally installed backwards, and I think I can show that with some of the earlier video. There, it eventually went poof, probably it was providing a little bit of capacitance backwards. Then the chip failed, and that fried the MOSFETs. They went open circuit, and that caused the fuse to go poof. I mean, not open circuit. They shorted all three pins together in the MOSFETs, and that caused the 300 volts that are between these two capacitors to go directly through the whole thing and naturally blew the fuse, which is good. So if this doesn't work, there also are a bunch of, you can see 1, 2, I can't really point, but if you look right in the center of the image, you'll see there are 3 transistors there. I'm not entirely sure what they do. I don't obviously have a schematic for this, but my guess then goes into some sort of 4 transistors actually there, and there are another couple back here, I believe. They could be related to its ability to power down or operate in a low power mode, or I don't know. And without the schematic and whether I'll be able to figure that out, I don't know. But I think it's an active component that's dead. I don't think it's going to be a diode or a resistor. I can check those in circuit, and I suppose that would be the next step. But I would then go in, there's one of these transistors as possibly being the problem. And yeah, you can see there are 2 over here, sort of in the center bottom of the frame. Right, so those have got to be involved in signaling of some sort. Anyway, I think they're labeled U2 upside down at the center bottom. That looks to me like an opto-isolator. So there is some signaling going of some sort. But I don't really think it's a regulated power supply. I think it's essentially a very traditional hi-fi type power supply of some sort. But, you know, where's the regulator? There's the regulation. It isn't obvious how that works, but might have to do with all those transistors. Anyway, well, it's a bit beyond me. I'm just replacing parts that obviously seem to be associated with the burnt out component, and we'll just see how that works. And ones that I obviously test bad, like, you know, the MOSFETs. Okay, well, I think it's been long enough. I'll put a power cord on first. I've put in a couple of screws just to hold things together. We'll see if we get a power LED. If we do that, then I'm fairly certain it will work. If we don't, then the question is, how much do I want to poke around it with 340 odd volts between these? Again, well, we'll see. All right, let's do it. Here we are at the moment of truth. First we'll power it on and see if the magic smoke comes out, I mean. Let me just remember where the power switch is back here. Ah, there it is. Okay, contact. Well, there's a slight flicker from the fluorescent, which, as I mentioned before, is conventional ballast. So we have no power light. So let's have a look at some of these pins back here and see if we can see anything. I will do that, and I will let you know what I see. Checking the voltages along here didn't show much of a change from before. I'm going to unplug it, pull the board out, and just see if there's any sense that there's anything on the primary of this transformer. That's really what we need to see, right? If there's anything on the primary of this transformer, then this whole part of the circuit is probably working. So nothing's plugged in here, as I will mention as I'm about to stick a screwdriver into something that should have a few hundred volts on it. I'm going to be very careful. I've actually moved my test stuff all the way over to the right side of the desk here, just so I'm not reaching over anything. because as we saw before, the two capacitors, which are here and here, those will have well over 300 volts on them. The primary of the transformer seems to be here and here. Here and here, I think. Something like that. So something in there should have quite a lot of AC on it. The secondary is here, I think. As you can see, that they're the two diodes, right? And this comes down to one diode, and this goes over to the other diode, right? And opposite sides. So this is going to be the secondary side of the transformer there. So, yeah. Let's see what the primary is. I do note the isolation in this thing is pretty good. There doesn't seem to be AC on either side of this transformer. So there's plenty of DC on the MOSFETs, but there doesn't seem to be any action. Actually, I'll do two things. The first thing will be to since this is out, to put an oscilloscope probe on the Handtech, which is over here, and see if there's any sort of waveform of any sort over there. With the probe on 10 time, I have enough headroom for 340 volts, so it should be okay. And again, right, not grounded. But I'll check the output first. Before I do that, I didn't check for DC on the diodes, which would have answered that question too, I suppose. But anyway, let's do it this way since I've got it. And then the next step will be, I will actually put this back in the speaker cabinet and plug in the speaker just in case everything does need to be plugged in for some reason. I don't think that's going to work. And then next step beyond that is going to be to just find the pin out of this chip and see if it's actually doing what it's supposed to do. And then we'll take it from there. I'm feeling less positive about getting this working, but it's been an interesting journey so far. So it's unplugged now. Flip the switch just to make sure here. Yeah, I don't detect any evidence using either the oscilloscope or the meter of anything on the primary and anything on the secondary. So something in here is still pretty badly cooked. There's 320 whatever volts on here. It floats up to 375, but there's even the meter pulls it down to 326 or 327, something like that. So that makes sense, right? So that seems to be what it does between those two capacitors. And so one shows up in the center pin of this MOSFET, and the other one comes around like this. And it ends up on the other half, right? So this here is I'm thinking this pin maybe, and that one. It's not quite clear to me what's driving the primary, but I'm pretty sure one of those two pins is the primary. You can almost see it through the other side here. And there's the transformer, so it's got to be one of those two, maybe that one, and then So that's effectively the ground for practical purposes. I have no idea whether it's negative or positive. I don't remember. But that's effectively the ground for this. On this side here, you can see that it's hooked in via that to the actual ground, right? So there are a few spots where it's tied to the ground here, which then ties through with those, I guess, class Y capacitors, whatever they are, the ones you use for that purpose. There's another spot here where we see it come over, and then here on the on the DC side, we can see that ground is tied as well. So yeah. So I'm not sure what I'm going to plug it. I'm going to try it in the speaker, but it's not going to work. So the question is then going to be, is it the chip, or is it something else? Or maybe it's something else. So then there are those transistors, which I'm not sure exactly where they are under here, and I'm not sure what they do. But then that'll be sort of the next step. I don't think I'm very likely to end up fixing this, and I very well may call the video here, at least for now, because I kind of need something to put up. So if anyone has any ideas about what could be wrong, I mean, I still think something in here. The thing is, whatever failed threw a lot of high voltage around, so the possibility of active components being dead seems pretty high. So yeah, so that's where I am with this. Well, thanks for watching my video on my attempted repair of this. What is the model number? I never can remember. It's not unplugged, but it is unplugged below. Yeah, Mission MS200 subwoofer with a dead old power supply. Thanks for watching.